Hello, and this is a part 2 of the session QAHO 2013. Again, reference number is of no importance because you already are seeing the handout right in front of you. But just in case, if you guys um, want to, keep the handouts with you by your side, that's also fine. Okay, so what I will do is I will start from where we left off. I think we had solved all the way till question number 8, if I'm not mistaken. Yeah, so we have solved till question number 8. Now we need to solve the rest of the questions, so let's do. Okay, again, question number 9 is also an application of the same Euler's remainders theorem. So let me just take my area where I need to work. All right, so let's take the first question from 9 onward. Question number 9 says find the remainder when 83 raised to the power 222 is divided by 16. Now, please remember we are using Euler's expression or Euler's remainder theorem. So typically what I will ask you to do is I'll ask you to find out the totient function of this term, totient number of this denominator 16. That is very easy. Again, the if you remember that 16 is nothing but 4 square, that is in fact 2 raised to the power 4. Okay, so the only expression to calculate, or the only thing that I need to calculate, will be 16 into 1 minus 1 by 2, that is 2, that is 8. So in fact the totient function of 16, or totient number of 16, comes out to be 8. Now I need to make sure that this power which on which it is 83 is raised to, one way or the other we need to reach 222. Okay, I don't know if I am able to explain. Let me change the color. Okay, the color is not making sense to me. So so let's check. Okay, this is a big enough number, so we'll have to actually divide it. So you can do it mentally also, but for the sake of simplicity I'm dividing. So 8 2s are 16, and this becomes a 6 2, and 7s are 56, 8s are 64, so 7s are 56. Now at this point I don't care. Okay, the remainder, whatever remainder comes in, I don't care. What I am interested in, the multiplication of these two numbers, 8 into 27. I know 8 into 7 is 56, 16 plus 5 is 21, so 216. So if you realize, I can raise 8 all the way till 216, but not beyond that. Okay, what I'm trying to tell you is that if I rewrite the expression, okay, let me change the color to some other color to make it a little visually appealing. What I'm asking you to look at this as, this is 83 8 27. Okay, this is 216, and how many 8s will be left? That is 8 raised to the power, sorry, 83 raised to the power 6. Okay, I hope that makes sense. Divided by 16, this is the remainder. You have a multiplication sign over there. Now the Euler's theorem says that this part, the remainder, will come out to be 1. That is the Euler's remainder theorem. All I need to worry about is this 83. Now let's see how I can manipulate this 83. Okay, now this would become a little challenging for me to explain, because, or let's say if at all it becomes challenging or whatever, let's not highlight too much. So 16 5s is 80. So this is going to be 3 into 3 into 3 into 3 into 3 into 3. Let's club them. 1 2 3 4 5 6. Yeah, so this is a 9 9 and 9. Okay, let's club these two and make it a 81. If you club this 81, you know that the remainder from this part is only 1 into the remainder from this part. This part I will only get 9, because 9 is less than 16. So ultimately the answer will be 9. So yeah, it just, it just depends on how you're looking at the questions, or how you're choosing to look at the questions. Okay, I will show you the answer also. I am showing you the answer. This is the answer. This is how they have solved. They did a similar technique. Okay, 3 raised to the power 4 raised to 55 into 3 square. I don't know what they did, but I'm pretty sure that the answer they will also reach at this thing only. All right, let's go to the next one. Okay, you just have to also understand that, because effectively what we are doing is we are number crunching, and sometimes number crunching becomes a little difficult also. So it's not like I'll always get the right, how shall I put it, the right inputs at the right time. So we're looking at the 10th question. Now this was one of those questions which I thought was really decent. 3 raised to the power 666 divided by 182. And at this point, if you haven't solved it or tried it, I would really encourage you to pause the video and try this out, because this is a very interesting one. If you see, the numerator is a very small single digit prime number, okay, and that has been raised to a humongously big enough power, which is a 666. One thing that I have, taught you in the concept classes is that in that kind of a scenario where you have a very contrastingly different sizes of the numerator and the denominator, what we try to do is we try to come up with numbers like 24 by 23 in the numerator denominator, or we try to come up with some numbers like a 21 or a 22, so that the remainder that I get from these effectively makes my life easier in terms of calculation. So one way or the other, if you understand what I'm saying, your brain will also come at the same idea. Unfortunately, with 3 I can't do much, because with 3 I can only increase the number 3 in the powers of 3, and they will very easily increase in, very big stages. Okay. Arey, yeah, just a second. I'm sorry. I'm really sorry. I don't know why this pen tool is giving me a hard time today. Okay. All right. So let's recall 3 raised to the power 1 is 3. 3 square is 9. 3 cube is how much? 27. 3 4 is how much? 9 nines are 81. 3 fives is how much? Let's do this. 3 2 4 3. And 6 let's do this. This is 729. Now, I don't know how long it will take for you to reach to this stage, but if you haven't reached it here, don't worry, eventually you will reach what I'm doing. The explanation I'll show you how they have explained, but I don't think the explanation will make any sense to you. 182 into 1 is 182. Okay, obviously I'll have to multiply. I cannot raise it to some number, because otherwise it'll become very difficult. This becomes a 4 and a 6 and a, let's say, 3, if I'm not mistaken. Yeah, 2 8 is 16 and 3. This is 182 into 3. Let's see. 3 2s are 6, 3 8s are 24, 546, and into 4 gives me 8, 32 and 728. Now my dear friends, I know that this will take some time, but the questions have been designed in such a way that you should find, again I'll reiterate myself, what is it that we're doing? We're number crunching. We're trying to crunch the numbers. We're learning how to play around with numbers. So what I will do is I will try to transform the numerator to 729, and I will transform the denominator to a 728. Okay, that will make my life easier. So let's do that. Let me take the red color. Yeah. Okay, so 3 raised to the power 6 raised to the power 111 by 182 into 4. Because I'm multiplying a 4, I'll have to multiply a 4 in the numerator also. This becomes a 729 raised to the power 111 by a 728 into a 4. Okay. Now this part, my dear friends, is equals to 1 raised to the power 111. And please remember 4 by 728. Okay, just a second. Hold on. This is as good as 182 into 4. This is the remainder because I'm just separating the two. 4 and 4 cancel. 182, the numerator is a much lesser quantity than 188. So the ultimate remainder is 1 and not 4. And this, I think, is one of those questions which will really test your patience. Either you will learn this or you will not learn it. Maybe you will appreciate it after some times. So, and let's look into the answer explanation. They have just given you that you multiply a 4 in the denominator and the numerator, and that's it. But actual remainder is 1. They have given you this thing. So yeah, that's pretty much the same idea. It's just that you'll have to appreciate it, because I don't see why students will be able to understand this at the first go just like that. Okay, now let's go to the other set of questions, 11, 12 and the ones. All right. Okay, the first question, 12 factorial divided by 13 divided by 13, find the remainder. Now this is Wilson's remainder theorem. Okay, for those of you who have gone through the concept classes, you know what Wilson's remainder theorem is. If you don't know, basically there are 3 cases of Wilson's remainder theorem, so you just need to understand which case has been provided to you. The first case is, I'll tell you, just give me 1 second, let me sip some water. Okay, and if you see, the question type has also, in this PDF also, you will see that the 3 questions, 11, 12 and 13, they are also the 3 types of that Wilson's theorem. So you don't really need to worry too much about it. Okay, so the first one, if the form is like p minus 1 factorial divided by p, and we are asked to find the remainder, this is straight up, the remainder straight up is p minus 1. That's it. This is the remainder. Okay. There is another condition. The condition if says that if instead of p minus 1, it is p minus 2 by p minus 2 factorial, okay, divided by p. The remainder in this case, straight up, the remainder is 1. Okay, these are the cases. There are only 3 cases, and don't worry, you will remember everything like, I am explaining it over here, because there are only 3 cases. The third case is, and you guessed it right, it is p minus 3 factorial by p. Okay. The remainder, now this one is a little tricky. This is p minus 1 upon 2. This is something that you would have to remember, or your faculties would make you remember this through some methods. I will not ask you to remember them or by heart them. One thing that I will tell you is that if you are my student, I would have given you logic. I'll give you the logic in this question also. Okay, as in when required. So this is it. So the remainder, Wilson's remainder theorem basically deals with factorial and stuff. Let's look into the first question. The first question says, find the remainder when 12 factorial is divided by 13. Okay, 12 factorial divided by 13. Please remember, 12 factorial is what? P minus 1. So what is going to be the answer in this case? It's straight away going to be P minus 1, which here is 12 only. So the answer is P minus 1 factorial by P. This is the case that we are using. That is 12. Now let's look into the next one. The next one says 11 factorial divided by 13. 11 factorial. Okay, let's do 11 factorial divided by 13. This is which case? Factorial P minus 2 by P. This is straight up 1. So the answer to this question is going to be nothing but a 1. Now the last one, remainder when 10 factorial is divided by 13. And you may choose to ignore this, or you may choose to remember this as is. Chances of getting asked this type of a question in CAT is also very less, but again, I'm just going to tell you for the sake of it. 10 factorial by 13 remainder. which case we are looking at p minus 3 by p minus 3 factorial. Okay, I can use the exclamatory sign also for factorial, but I am okay with this one. And here you will do p minus 1, that is 13 minus 1 by 2. 13 minus 1 is 12 by 2, that is 6, and the answer to this question is 6. Now, only to cater to the students who think that they can understand this, I'm going to give you an alternate method. But again, let me tell you that alternate method is just playing around with numbers. So the 13th question I'm going to be solving in a different way. Okay, I will try at least to solve it in a different way. What I will do is, I need to find out the remainder when 10 factorial is divided by 13. So let's use the appropriate Wilson's remainder theorem, which is factorial p minus 2 divided by p. That is the remainder of the case when it is, just a second, sorry, this is a little not too visually appealing, factorial p minus 2, and the remainder in this case is 1. Okay, I'll reiterate myself, factorial p minus 2 by p is equals to 1. Now, just now we have seen that factorial 11 is a, it when gets divided by 13, the remainder is 1. So in the terms of dividend, divisor and remainder, I can write it in terms of like this, 13q plus 1. Okay, I'm just explaining or trying to give you a logic. Now, okay, just hold on. Let me, get the another color. What is this? Have you ever heard of this fact? Dividend is equal to divisor into quotient, whatever arithmetic operation, and remainder. Okay, this is Euclid's division lemma, EDL. So dividend is equal to divisor into quotient plus remainder. If you don't know anything about remainders, at least this much you should know. This is the Euclid's division lemma. I have taught you this thing in the concept classes for you. Here is the explanation if you must. Okay, here is the explanation if you must. 13. So I'll give you some time. So if you want to probably take a screenshot or something, you can take it, you can read it. Wilson's theorem says that, the same idea you can use. I've explained it. If you see what they have done over here is, they have very easily written 11 into 10 factorial minus 6 is equal to 13q minus 5. RHS is a multiple of 13. So 10 minus 6 has to be a multiple of 13. Why? Because 11 is a number. 11 can't be a multiple of 13. And that is why they are, effectively they're using the logic that 10 minus 6 has to be a multiple of 13. Because 10 factorial minus 6, not 10 minus 6. So if that is the case, 10 factorial minus 6 is equals to 13p, I can write. Then I can also write 10 factorial is 13p plus 6. Now that is where your division lemma comes. Dividend is equal to divisor into quotient plus remainder. This is the remainder, this is the divisor, this is the quotient. I don't care about the quotient. All I care about is the remainder and the dividend. Dividend is the 10 factorial, remainder is the 6 one, and divisor is 13. That is what it is. Quotient we don't care. I don't know if you can see it, but possibly you can zoom in a bit. You can use your methods. Yeah. Let's look into the last two questions. And these last two questions are not at all difficult. They're, and I mean, again, I'm reiterating myself, but if you can just remember it through the formula, and the formula is that p minus 1 upon 2, that basically does your job. These three Wilson's remainder theorem will only come with this much logic only. P minus 1, p minus 2, and p minus 3. P minus 1 is p minus 1, p minus 2 is 1, p minus 3 is p minus 1 by 2. Okay. No chances at all coming in cat, but then because we are discussing the handout, I am giving you the idea. Otherwise, I would have not wasted my time. Anyways, let's look into the 14th question. Okay. Hold on. Yeah, so the question says that find the remainder when 16 factorial. Okay, 16 factorial raised to the power 39 raised to the power 30. Now this one is an interesting question. Divided by 19. There is something that we can actually do with this thing. Now in this question we will actually employ the Wilson's remainder theorem number 3, the application one, which is factorial p minus 3 by divided by p. And you know, all these logic, I have told you that this is going to be p minus 1 by 2. P is 19 minus 1, that is directly, I want the answer directly, that is 19 minus 1, 18 by 2, that is 9. I hope that makes sense. So effectively this thing can be written as, let me change the color, 9 raised to the power 39 by 19. Okay. Can you use Fermat's little theorem? Can you use Fermat's little theorem, Fermat's, you know, remainder theorem or Euler theorem or whatever to predict the answer? And the answer to that is yes. Okay. 18, 19 ka 19 is a perfect prime number, sorry, it's a prime number, so the quotient of 19 is going to be an 18. Okay, and 18 twos are 36. Okay, so effectively I am just left with 9 raised to the power 3 by 19. In other words, I am getting a 9 into 9 into 9 by 19 remainder. My dear friends, I don't think that it will take you any time to solve this question. Okay, but still, because you know I have to do it, I'll do it. So this is again 81 into 9 by 19. 19 fives are 95, so don't do that mistakes. 19 fours are is how much? Have I done the calculation somewhere? Okay, 76, right? So this is 81 minus 76 is a 5. 5 into 9 is a 45. 45 by 19 remainder. So this will be 38 and yeah. So 45 minus 38. I hope you can see what I'm doing. 19 threes are 19 twos are 38. So this is 15 minus 5 is 10 minus 2 is 8. Okay, I hope I'm not making any mistake. Okay. No, wait. 15 minus 5 minus 3. This is 7. Yeah. Okay, this is 7. So the remainder, ultimate remainder to this question is 7. It is not anything else. So this is how I would have thought in an exam condition. This is what I would have done in a situation. Can I make it more elegant? I don't know, maybe. But then this is how my mind works. I have shown you the technique. Basically just reduce the numbers, yeah. Let's go to the last one. This is a good one. Find the remainder of 1 factorial, 2 factorial till 90 factorial divided by 42. All right, so this is an interesting one, and then I don't think that question number 14 had some value. 15 has no value. I'll tell you how. Okay, so we will look into this question now. Question number 15, factorial 1 plus 2 plus factorial 3 plus factorial 4 all the way till factorial 90 divided by 42. Effectively, basically what we need to look out for is the remainder when we add this summation. So factorial 1 by 42 is 1, 2 by 42 is 2. I'm just writing the remainders. 3 by 42 is a 6. 4 by 42, factorial 4 by 42 is a 24. And but you know, till so far no problem. But I need to see for the rest number, that is factorial 5 plus factorial 6 and so on. Okay, but please pay attention, factorial 7 onwards, factorial 7 onwards, what I will get is factorial 7 is a what? Factorial 7 is a 7 into factorial 6, whatever that number is. Okay, or let's say 7 into 6 into factorial 5, let's see, by 42. Now this is a 6 and a 6 cuts out. So if you realize that the remainder, there is no remainder. Okay, It's not even a case of a remainder, it is actually divisible. So factorial 7 onwards I will not find anything, so I'll only have to check for till factorial 6. For all the way till factorial 4 I have checked. For 5 and 6 let's check. Factorial 5 for all of you, you know it is 120 by 42. Let's calculate the value. Obviously, I mean, you can employ some technique, but then it is better to just, you know, use the division methods. If you just look at the number 42 into 3, that is 124, more than 120 in the numerator, so it will have to be 2. So 120, and this is 84. 10 minus 4 is a 6, and 11 minus 8 is a 36. So I will add a 36 in the place of it. What about for factorial 6? For factorial 6, I can see factorial 6 is nothing but 6 into 120 by 42. Now just now I have calculated this part to be 36. So I can just multiply a 36 into 6 by 42. Okay. So this is a 6, 6, 36. This is 216 by 42. 4 2s are 5 2s are 10, 20, 21. Yeah, so I think 5 times it should cancel, right? 42 into 5. Basically what I'm doing is I'm looking out for 42 into 5. So 5 2s are 10, 1 5 4s are 20, 1 is 210. So this is 6. So this will be 6. And factorial 7 onwards you will find 0 remainder. So this is what it should look like. Let's just see what I'm getting it. So this is 34, 24 plus 36. This is 30, 20, 50, 60, 60, 66, 72, 74, 75. So I'm getting a 75. 75 when gets divided by a 42. The remainder is 33. So this should be the answer. 33 should be the answer. Okay. Because ultimately, see, after adding, you will have to find the final remainder, right? It's not like all the remainders you add and that is the answer. No. Once you get the remainders, you add all the remainders, and the remainder in this case happens to be a 75, which is more than the divisor. So you'll have to again do the division process, and 42 2 is 84. So 1 times it will go. 33 should be the remainder. Let's check. Yeah, so 33 is the remainder. But obviously, if you can see, they have employed some different tactics. They have done something. They have arrived at a 873 by 42 and so on and so forth. I don't know. And yeah, so any factorial from 7 onward is divisible 43. 43. What is 43? You know, maybe some typo or something. I don't care. Yeah. So finally, I have solved the rest of the questions also. And for the additional practice problems, that is something, you know, I don't think I should look for. I'll tell you why. Because these are, you know, these are brain teasers, so you can possibly take a screenshot, and if you want to maybe practice them, you can practice them. But or maybe I'll take another session